morning. I'm Daniele Lezzi. I'm a senior researcher at the Barcelona Supercomputing Center. In this video, I'll cover the iSprint design tools layer of the iSprint platform. First of all, at this level, we have the following users of the iSprint platform. We have the application developers who know the problem, scientific problem, explore possible implementation for their applications. This application can be written using the iSprint design parallel tools that we will see later, and the application can be also composed of functions that can be executed independently as a service on the virtual infrastructure. Then we have the application architects and managers who defines the architectural elements of the EI application, optimize the application configuration, and finally we have the end user who collects the data, prepares the dataset for the algorithm, and executes on the platform the application that consumes data across the edge to cloud continuum resources. So the first stage, as we can see here, of the development of the iSprint application design workflow consists in the application definition, in which application developers and application architects provide the implementation code using, for example, the parallel programming model of iSprint and the configuration files to prepare the application for the following steps for the execution of the application. These steps include the execution of the design and performance models tools that will help to provide the optimal application deployment and components placement on the virtual infrastructure, as explained in another video. So looking at the details of the iSprint platform, we concentrate on here on the left side, where we have the set of tools used by application developers. The iSprint Studio is a software package available as a Docker container and includes all the open source tools that are also made available on the iSprint website. The design and programming abstraction group here on the top provides a set of tools that hide the computing continuum complexity, map software components to candidate resources, specifying quality of service constraints. The quality annotations and the iSprint design tool allow enriching application with quality annotations to express performance, accuracy, and security constraints. The output of these tools are YAML files shared among multiple iSprint design tools, so here, and also input files for the runtime environment tools. Then we have the PyComps programming model, that is a framework that offers automatic parallelization of the applications, leveraging the user-provided information through input dependency annotations in the code. These annotations are used to drive the scheduling phase at the execution time. This lib is a parallel machine learning library built on top of PyComps that provides already optimized parallel machine learning algorithms, reducing the execution time of the training and inference processes, exploiting the inherent data parallelism of the input data. Here we have the Space for AID tool that performs and automates design space exploration in order to minimize the execution cost of the EI application. It provides response time quality of service guarantees by implementing several heuristic algorithms. Space for AID partitioner inside Space for AID, this tool selects the candidate cutting points for a deep neural network to identify multiple deployments of the underlying software component for which the inference can possibly be improved when run across multiple resources. PopNAS is a network architecture search tool that, given a level data set, provides the best deep network, solving, for example, image classification or image segmentation task. Toscanizer automates the generation of Docker images, including application components, their dependencies, and the required iSprint libraries. Toscanizer generates Oscar files for each component to be deployed and translates the computing requirements to the Tosca standard to communicate with the virtual infrastructure provisioning module. Finally, we have the performance model tools that provide the application manager with means to choose an appropriate configuration, for example, to avoid the application performance violation, under overestimation of the utilization of the resources in the computing continuum, and to predict the execution time of deep learning components on a target configuration. The final goal is to provide solutions for selecting the most appropriate system configuration for executing the required application component, inference pipeline, for example, training jobs, to fulfill quality of service requirements while minimizing operational costs. Finally, in this group, we have the Oscar P tool that profiles automatically Oscar and scale-based applications, including PyComps, for example, application, and automates the machine learning models execution. Oscar P explores different hardware nodes combination, obtaining relevant information on the timing of the execution of the individual components. So this is a brief introduction to the Sprint design tools. You can have more details in following videos. Thank you very much for your attention.